This is the supplemental lecture number 6 for the last week of JIT 70. All right, so there's only one section to cover, which is the topic is called the dimensional analysis. All right, so basically you're learning how to convert one unit to the other, and this technique will be common in any STEM course you take in the future. All right, example number 1, convert 5 inches to centimeter. All right, so you have to know that 1 inch equals to 2.54 centimeter, right? So inch is one version of the length unit, and the centimeter is another version. So you're converting the unit from one version to another. And then every single unit has their own dimension. That means the spacing is different for 1 inch and 1 centimeter. For example, so sometimes we convert the given unit to something else that we are familiar with more, and that's one purpose for the dimensional analysis and unit conversion. All right, so we have 5 inch given, and then we learned we have noted that we have to round the answer to the nearest tens, right? So that means you have to convert the number to something like XX. Approach should show you the symbols, right? So it should be something like 235.4, because the first digit, the first digit is the tens position, or it can be something like 0.8, and that is the right format of the answer, or it can be something like 15.2. But if you have something like 13.34, then that's not the right answer, because you're not allowed to show 2 digits. After 2, you're not allowed to show 2 decimal digits. All right. So to convert a unit, then we have to apply the fraction method. Right? Some people call that the fraction method, and then I'll show you the reason we are doing this in case you didn't grasp it. Right. Right. So we make up a fraction this way. Why? Because if you have 2.54 centimeter over 1 inch, these two dimensions are the same, because we know that 1 inch equals to 2.54 centimeter. So if you make up a fraction like that, then it's telling you that we have the same value divided by, we have the same dimension divided by the same dimension, which will give you 1, right? And that is crafted from the equation we have from before. It's just if you divide both equations sides by 1 inch, then you'll get that information, right? So if you multiply 5 inch by 1, then it doesn't alter the answer itself. It only alters the unit with different dimensions. So that is why we convert a unit in this way. And then you might go, hey, then why is the centimeter on the, why is 2.54 cm a numerator? And why is 1 inch a denominator? Well, yes, there is a reason we do this, because we want to divide out the inch unit. That's why. If we do that, then think about it. There's only a centimeter unit remains, right? And then that's when you plug in the numbers in your calculator for the answer. 2.54 times 5 gives you 12.7, and then with the remaining unit centimeter, and then that is how you show the answer in a unit conversion problem. All right. Example number 2. let's see, 1 mile equals to, we have to know that 1 mile equals to 1.609 kilometer or 1609 meter. M stands for meter. And then we also have to know that 1 meter equals to 100 centimeter. Right? All this info should be memorized because they'll be common, and then they'll help you convert the unit correctly when you talk to someone and when you help someone converting the unit in a scenario. Right. Then let me show you how the fraction method works here. So we have 1.4, we start with 1.5 mile. Then the fraction we should use is the one based on this info. If these two info equates, that means we have 1,609 meter over 1 mile, which equals to exactly 1 for that fraction. And then again, 1 mile is not a denominator because we want to cancel, no, we want to factor out the mile unit. And then this is the question for us to multiply another fraction because we eventually want the final unit as centimeter, right? We have 100 cm over 1 m. Why? Because m's are divided out. We have to divide out the m's. So what we have is 1.5 times 1609 times 100 in the centimeter unit. And that is how we get the final answer. And then that would be 241,350 point. We need a 10th decimal digit. So that's why we have 0.0 at the end. So this is your answer for the next example. All right, so I'll show you the wrong way. So if you have 1.5 miles and let's say, hey, I'm making up the fraction as 1 mile over 1609. So I know it's a fraction method, so it's okay if we swap the order of these two values, right? Well, you can't do that. All right, and this is the test for you. Pause the video and think about why. Why shouldn't we do that? All right, I believe you're finished that task. And then let me show you. The reason we can't do that is because we'll multiply the miles twice. Let me show you. If you do this, then you'll have 1.5 over 1609 with a with a more redundant unit set, which is miles squared over m. That doesn't help because you didn't simplify you didn't actually convert a unit. You're just multiplying more units to get something that is nonsensical. So that is why this method is wrong. You always need to have something on the denominator that divides out the previous unit for you to convert a unit. Make sense? All right, think about the mathematical reasoning instead of just getting things done. That's one of the last advice for you when you do math in college or in the future. Right, you're going to be professional in your field, then you got to know why we do things in a certain way. Okay, right, next, example 3. A room has 12.4 feet square of space. How many square meter is this? All right, so we got to understand the language we're speaking here. What do you mean by square meter? So square meter stands for m to the 2. All right, so this is the unit of area. Right, a visual may help. So if you have something like, if you have a furniture like table with the dimension as 3 meter times 2 meter, right? That's what you can see when you purchase something from a furniture store. But if you actually work on a map, then you have the area as 6 meters squared, right? And then visually, you're going to have the dimension like that. This is your 3 meter length, and this is your 2 meter width. And then the area is exactly the shaded area you're seeing. And that area is exactly 6 meters squared. You multiply two numbers and you get the meter squared for your result. Okay, right. Then our goal, and this is the specific conversion factor given, because that means you don't have to memorize this info. And then we are asked to round the answer to 1 decimal place. So let's do it. Put down the original information. We have 12.4 feet squared. All right. Then we want the unit as meters square at the end. So let me show you. We have, what do we have? We have 1 meter equals 3.28. And then you may go, hey, professor, then we can place the feet on the denominator, and place 3.28 feet on the denominator and 1 meter above, and cancel the units and problem solved, right? Okay. I tell you what, this is the biggest mistake in this type of problem. When you have area unit, then you can't multiply fraction in this way. Why? Okay, pause the video and think about it. This will be a common mistake I found. That's why I let you think about. So let me show you how to do things right. What we should do is to square the entire fraction. Why do we do that? Because we have to square everything on the fraction to cancel the info, correctly. And then let me show you slowly, right? If you square the entire fraction, then everything is squared. 1 squared, meter squared, over 3.28 square, feet squared. Everything is squared in the fraction. That is a rule we follow. And then now FT squares are divided out, okay? And then what would you get, right? You have 12.4 divided by 3.28 squared, and then the 1 square can be taken off when you do the math and reduce the fraction, because 12.4 times 1 square is still 12.4. Doesn't make a difference. So meter unit with square is there. So we call this meter to the 2 or meter squared. Square means the power of 2. Right. So don't forget to plug in the 3.28 squared into your calculator. It's very important for you to reason the math in this way. And then eventually you'll get the final answer in 1 decimal place, which is 1.2 meters squared. Right. So that is right. That is the answer. All right, I'll give you another fun fact. So why is 1 meter equal? Why does 1 meter equal 3.28 feet? All right, so here's our thinking. This is the fun knowledge for you to learn. So let's take a look. So we know that 1 meter equals to 100 centimeters, right? And then if you line up several food in this way, so let's say we have 4 persons lining up the food on the ground, then the average spacing, well, let's say that all the foods are identical, and then the average spacing of about 3.28 feet will be approximately 100 centimeters. So, right, so that means each food has a length of around 30 centimeters in average. So that's why we have 1 meter as 100 centimeters, which is equivalent to the lineup of 3.28 feet in that visual aid. Right. And then that's what the factor is from. It's fun to see this fact, right? So that will help us define 3.8 feet for the unit conversion purpose. All right, we can move on. Example 4. The acceleration of an object moving through space was measured at 16 feet per minute squared. All right, this is a physics application problem, but you don't need to understand what the acceleration stands for. Well, it's showing you the rate we increase the speed over time. And if you're interested, you can Google acceleration and figure out more detail, because that wasn't the main focus we have in this example. Right. So we have feet per minute, and then another thing I can tell you is that feet is actually FT. So it's the same as the FT we use above. Sometimes we just happen to use the two words interchangeably, which is totally fine. All right. We need a final unit in meters per second squared. All right, there's something else we should know. So first of all, we can tell that, right, 1 meter equals to 3.28 feet. I'm more used to the FT, so I will just turn the feet into FT instead, right? And then MIN means minute. 1 minute equals 60 seconds. That's also the conversion factor you should memorize. All right, then these are all the info we need for unit conversion. So let me turn that into FT. 16 FT per minute allows you to convert 2 units on the fraction until you get the right answer. So first of all, we can convert the length unit as 1 meter over 3.28 feet. And then there's no square on the first fraction because we have the feet given. All right, so this is when the understanding matters. You have to know when to apply the power of 2 and when not to. Okay. All right. We do that for the first fraction, and then for the second fraction, now we have to square the entire fraction because we eventually want the second squared on the denominator. All right, then I'll tell you what, feet units are divided out, minute squares are divided out. So we ends up having this. Combine all the factors. So you have 16 over 3.28 times 60 squared. Remember, we're squaring the entire fraction. So that's why we have 60 squared. Again, then the final unit will be meter per second squared. All right, plug in everything into a calculator, then you will, if you do it correctly, then you will get the final answer, which is what? That will be a huge number. And the huge number will become 188,928. So we need 3 decimal places, and then looks like there is an integer found in the calculator, and that's why we are using something 0.000 as and final answer. Wait, is that right? No, it's not. Right. So let me. I calculated wrong. It should be a small value. Right. 0.00136. We need 3 decimal places. So that's why we show 3 digits at the end of the value. All right, so that is the final answer in meter per second squared unit. All right, lastly, example number 5. Let's practice another one. Kitchen faucets usually have a flow of about 136.02 milliliters per second. So that means the flow rate of the water from a faucet. If you turn up the faucet, then you'll make when you make the flow a maximum, then you will have 136 milliliters coming out per second. So we need the final unit as gallon per minute. So we have to recall the gallon unit. So 1 gallon equals to something milliliter. And then, right, we just have a lot of information in this entire world, so we have to know what they are. 1 gallon. That's the unit for the gasoline in general. That equals to 3,785. And then normally we'll put down milliliter as ml for simplicity, because milliliter is a long word. Let me be more specific. 3785.4, right? That'll make your result more accurate. Okay, so let's think about this one. 136.02. If you have milliliter per second, then that will be ml over SCC. Okay. And then, first of all, we have to convert the capacity unit from milliliter to gallon. So what do? We define 1 gallon over 3785.4 ml. All right, in case you want to know the side knowledge, 1 gallon equals to something liter. That would be 3.785 liter. This is L is the more common unit you will see. So if you have 10 gallons of gasoline, then that means you have 37.85 liters added to your vehicle. All right, make sure you memorize those info because they will help. All right, no, we're not there yet. Yes, milliliters are divided out, and then another thing we should convert is the second unit, and then turn that into minute unit. So this is when we show the fraction as 60 seconds over 1 minute. And why do we do that? Because we want to cancel the second unit. All right, and then this is when you combine all the values. 136.02 times 60 over 3785.4. That'll give you a finalized unit, which is gallon per minute. All right, then you plug in all the numbers into your calculator. Then you have 2.1. They don't have the rules about the decimal places, so you can make up whatever you want. That'll be 2.16 gallon per minute. All right, problem solved. So whenever you convert a unit, you have to apply the fraction method like this all the time. All right, so congrats, you have finished the last supplemental lecture video, and I hope you learned something useful from it. All right, make sure you practice more, and then I'll see you around.